Hi, this is Scott Forbes and welcome back to our Wednesday edition of science class here. If you check out the Wednesdays, I was trying to think of a good way to use Wednesdays. And instead of plowing forward with curriculum, we are, but what we're doing really is going into the textbook. I assign pages 1 to 10 of the textbook. Now, if you don't have a physical textbook yet, let me go off screen. If you don't have this physical textbook yet, which you probably don't because we haven't handed them out yet, and there's a couple here on campus, but there is a PDF of it available, portable document format in your Google Classroom, so do look for that. I know it's not the easiest sometimes to read off of a PDF, but we're going for some of the major concepts in there that I'll show you when you're reading a textbook like this, how you want to read a textbook, how do you want to approach it. If you want to get a great night's sleep, try and read a textbook from beginning to end straight on through. I guarantee you'll be sleeping soundly after the first couple of pages. Textbooks are not like novels. There's no young kid going off to Hogwarts, or there's nothing exciting going on in there plot-wise. Textbooks are for information. It's informational reading. We're going to go through some techniques on how you can actually address informational reading. So here we go. Let's jump into what those first 10 pages were about, the major things that I want you to know going into those first 10 pages. First thing, those first 10 pages, they talk about, is it alive? One of the things in biology class that you start off with is, how do you know something is alive or not? Now, I'm going to say something that I think might possibly maybe surprise some of you. If you look at the fact that we're doing this distance learning right now, doing YouTube videos and Google Classrooms, and we had our Zoom meeting today, this is caused because of a virus, COVID-19, of course, and we're trying to keep people from getting this virus. So we're, of course, keeping social distancing until we can work on a vaccine and until we can get the numbers to go down. But here's the thing, a virus is not a living thing. So wait a second. What do you mean it's not a living thing? I've had colds before, that's caused by a virus. Chickenpox, measles, you've heard of viruses lots of times. A virus in and of itself isn't alive. So this entire pandemic is caused by something that's not living. It doesn't even move itself. It requires a host, in this case, us, to go from person to person. That's why we're doing social distancing. A virus is called, by many scientists, a virus particle. It attaches to a cell, and then it kind of takes over the cell. We're going to spend a lot of time learning about viruses this year. Not only is it part of the curriculum anyway, but especially this year, it's a perfect time to talk about it. But a virus is an amazing thing. When I first learned about viruses many, many years ago in school, I was shocked. They're this non-living thing that attaches to the cell and then takes over. That's astonishing. If you look at some of the things that we talk about, I don't know if I'll be able to use it this year, but we used to use the movie where Mark Watney goes to Mars and he gets stuck there and he has to grow potatoes and so forth. It's a fantastic movie. It's called The Martian, by the way. It's a fantastic movie and book to use. Would you use little excerpts from that? I'm not sure if we're going to have to use it this year, but we're still sending missions to Mars. And if you look at the Mars missions, that's going to come up here in just a second, the Mars missions are looking for life, or at least evidence of past life. It's one of those things that is key to the Mars missions. How do you know when you pick up a scoop of Martian soil, it's not really soil, but when you pick up a scoop of Mars, how can you tell if there's any living things in there? So that's what we're checking out. One of the things that we start with in these first 10 pages is measurement. As a matter of fact, we talk a little bit about geometry right off the bat. And when you look at geometry, geometry literally means to measure the earth. And geometry, the measurement of our planet, was first carried out pretty accurately by a guy by the name of Eratosthenes. We'll talk about that. More than 2,000 years ago, he was able to very accurately figure out the size of the sphere upon which we live. That's more than a little bit astonishing. They talk a little bit about the metric system in these first couple pages. The System International. The System International, I'm using the American spelling up here. It's usually referred to as the metric system here in the United States. The metric system is what we use in science to be consistent from scientist to scientist when we're looking at measurements. Let me give you a quick example of that real quick. If you look at 1 meter being the same thing as 100 centimeters, it makes it extraordinarily easy to convert between centimeters and meters. You're just hopping decimal points. If you check out 1,000 meters, if I take 1,000 of these, 1,000 meters, and stretch them out, place them end to end, you've got yourself 1 kilometer, 1 click if you know somebody in the military. Let me show you why this is a much better system to use than what we're using in the United States, and also where it comes in handy with this one special thing that our textbook doesn't talk much about yet, but will, and that's conversion factors. One other thing too I want to mention is CPM. You guys are undoubtedly looking at the first 10 pages of the science book and going, wait a second, Mr. Forbes is trying to sneak in some math on us. Yes, absolutely. Math and science go hand in hand. Math is the language of science. We have to be really good at our math to really go deeply into the science. And if you check out your CPM books, I'm going to give you an example where there's a lot of crossover between the CPM and the science classes. So here we go. If you look at one cool thing, conversion factors. 1 centimeter 1 inch is equal to about 2.54 centimeters. If you look up here, I made a little typo that should say 1 inch. 1 inch is about 2.54 centimeters. So if you're looking at a conversion factor, let me change that to 1 inch. I just noticed on the board was incorrect. If I have 2.54 centimeters at the top of a fraction and 1 inch at the bottom of the fraction, that's the same thing. If I have 1 inch at the top of a fraction and 2.54 centimeters at the bottom of the fraction, that's exactly the same thing. This is called a conversion factor. It's basically just a fraction where the top value and the bottom value, even though they look different, are really the same thing. In your CPM books, your CPM math books, they call this a giant 1. I think they call it a big 1 or a giant 1. When you come across it, what they do is they show a big superimposed 1 over conversion factors. Here's an example of our goofy American system that we're using, standard system. 5,280 feet is 1 mile. Now in the metric system, it's really easy when you're talking about big distances. You know, kilometers, 1,000 meters, right? But we have a lot of goofy conversions here, or things to remember in our system here that we use in the United States. We have 3 feet for 1 yard. We have 5,280 feet is 1 mile. With the metric system, there's much less to remember because you're just hopping decimals. Check out this as a conversion factor. Let's say you go up into class when you end up back here in school, or if a teacher asks you to do it online, you know, Miss Eifert, Mr. Bolter, Mr. Sewell, they say, hey, today we are going to run the mile. And everyone goes, oh no, I don't want to run the mile today. It's cold out there. All right, we're not going to run the mile today. Tell you what, we're going to run 5,280 feet instead. And people who don't know the conversion factor is like, oh yeah, that sounds much better. It's the same thing. A conversion factor is used in science, it's used in math all the time to convert from one unit to another. The reason, one other reason that the metric system is so awesome to use in science is this, check it out. This right here is a tiny block, and I'll go right up to the camera. It's one little itty bitty block, and each side is 1 centimeter. So this makes it 1 cubic centimeter since it is a cube, a little tiny cube that's 1 cubic centimeter. In the metric system, when you're using volume, and this is right here, some colored water in a graduated cylinder we had in the first chapter there. This particular graduated cylinder holds 250 milliliters of water. Now if I look at this graduated cylinder here, and I look at this solid block here, if I wanted to convert between the two, the metric system does this incredibly cool thing. They make 1 centimeter cubed, the same thing, the same volume, takes up the same amount of space as 1 milliliter. So if you want to convert between the two, it's the same thing. In other words, if I were to take this 250 milliliters and pour it into a cube-shaped container, it would take up exactly the same space as 250 of these little blocks. Metric system is super, super easy to use. It's completely awesome. And that's why they talk about it right away on the first 10 pages of our book. So, quick recap of the first 10 pages. We talk about, hey, what's alive? How can you tell it's alive? We'll spend a little bit of extra time tomorrow on our video lesson talking a little bit about viruses and why we consider them not to be alive, which is a wild thing when you think that it's shutting down schools and businesses right now, but they're not even living. Why is that? How does that work? You guys, by the end of this year, over the next 36 weeks, are going to become experts at what is a virus, where did they evolve, how long ago did they evolve, and why right now are we having such trouble with shutting down COVID-19, making it stop passing from person to person. That's one of the things that's going to be a thread through our year that we're going to learn about. Have a great day. I hope the pages 1 to 10 are pretty easy to read in your portable document format, and we'll jump on in with tomorrow's Zoom meetings for first, second, and third period. Take care, everybody. Bye-bye.